Back in ICE, we'll use a new node that will allow us to take the particle's position and have them find their closest location on the object from which they're emitting and are supposedly moving across. If I look under the tool nodes and I look under geometry queries, we can get the closest location between our particles and the geometry. If I pull it into my graph, it's asking me for a geometry, so the geometry I want to measure closest location from, and that would mean this grid. If I press F3 and I pull it in, I'll use the output of that object as the geometry input for the closest location, and I'll use the particle's position as the 3D vector per point of my cloud. So if I actually look up point or particle, get the particle position and use it as the input. So I'm measuring the closest location between these two, and the result is a location per particle on the grid. And I need to convert that location per particle, so you can actually see here it's a location on our grass polymesh, but it's a location per point of the point cloud. And I want to turn that location into a position. So from this location, I can pull the particle position. And I can do that using a getData node. And the reason we need to use a getData node here is because I can't just get the particle position again. I need to get the particle position at the location. So my context here is based on location, but it's the location on the actual grid, and I need to get the location back in the particle space again. So I'm basically chaining the point cloud's position from location. So I'm getting point position from location, and the point position is referring to the self object in order to the point cloud. Now that we have context again, if we look at our output, our context now is a 3D vector per point of our point cloud. Well, now I can actually set the new point position. So if I look under particle once again, you'll notice that you can actually interchangeably use set point or set particle. It's still referring to the self object dot point position. So I'll find the set particle position compound and output my get point position. And then it's just a matter of setting the point position back on the ice tree. If I minimize and press play, we'll see now that all of these particles flow across the surface. So our node is working. If I actually move to frame 2 and I was to do any sort of modifications to the grid, you can see that the particles will just follow the height. So that's a good thing. It means we can alter our terrain quite extensively and still have the particles respond. So it's a very dynamic tool that we're building. Alright, so we have another one of our problems checked off on our crowd checklist.